A markup language is a system for annotating a document in a way that is syntactically distinguishable from the text. The idea and terminology evolved from the marking up of paper manuscripts, i.e., the revision instructions by editors, traditionally written with a blue pencil on authors' manuscripts. In digital media, this blue pencil instruction text was replaced by tags, that is, instructions are expressed directly by tags, or instruction text encapsulated by tags. Examples include typesetting instructions such as those found in troff, TeX and LaTeX, or structural markers such as XML tags. Markup instructs the software that displays the text to carry out appropriate actions, but is omitted from the version of the text that users see. Some markup languages, such as the widely used HTML, have predefined presentation semantics, meaning that the specification prescribes how to present the structured data. Others, such as XML, do not. Hypertext markup language, one of the document formats of the World Wide Web, is an instance of SGML, and follows many of the markup conventions used in the publishing industry in the communication of printed work between authors, editors, and printers. Types. There are three main general categories of electronic markup. Presentational markup, the kind of markup used by traditional word processing systems, binary codes embedded within document text that produce the WYSIWYG effect. Such markup is usually hidden from human users, even authors or editors. Procedural markup. Markup is embedded in text and provides instructions for programs that are to process the text. Well-known examples include troff, TeX, and PostScript. It is expected that the processor will run through the text from beginning to end, following the instructions as encountered. Text with such markup is often edited with the markup visible and directly manipulated by the author. Popular procedural markup systems usually include programming constructs, so macros or subroutines can be defined and invoked by name. Descriptive markup. Markup is used to label parts of the document rather than to provide specific instructions as to how they should be processed. Well-known examples include LaTeX, HTML, and XML. The objective is to decouple the inherent structure of the document from any particular treatment or rendition of it. Such markup is often described as semantic. An example of descriptive markup would be HTML's NLT, cite and GT, tag, which is used to label a citation. Descriptive markup, sometimes called logical markup or conceptual markup, encourages authors to write in a way that describes the material conceptually, rather than visually. There is considerable blurring of the lines between the types of markup. In modern word processing systems, presentational markup is often saved in descriptive markup-oriented systems such as XML, and then processed procedurally by implementations. The programming constructs in procedural markup systems such as TeX may be used to create higher-level markup systems that are more descriptive, such as LaTeX. In recent years, a number of small and largely unstandardized markup languages have been developed to allow authors to create formatted text via web browsers, for use in wikis and web forums. These are sometimes called lightweight markup languages. Markdown of the markup language used by Wikipedia are examples of such wiki markup. History, etymology and origin. The term markup is derived from the traditional publishing practice of marking up a manuscript, which involves adding handwritten annotations in the form of conventional symbolic printers instructions in the margins and text of a paper manuscript printed proof. For centuries, this task was done primarily by skilled typographers known as markup men, or copy markers, who marked up text to indicate indicate what typeface, style, and size should be applied to each part, and then pass the manuscript to others for typesetting by hand. Markup was also commonly applied by editors, proofreaders, publishers, and graphic designers, and indeed by document authors. GenCode, the first well-known public presentation of markup languages in computer text processing, was made by William W. Tunnicliffe at a conference in 1967. Although he preferred to call it generic coding, it can be seen as a response to the emergence of programs such as Runoff that each used their own control notations, often specific to the target typesetting device. In the 1970s, Tunnicliffe led the development of a standard called GenCode for the publishing industry and later was the first chair of the International Organization for Standardization Committee that created SGML, the first standard descriptive markup language. Book designer Stanley Rice published Speculation along similar lines in 1970. Brian Reed, in his 1980 dissertation at Carnegie Mellon University, developed the theory and a working implementation of descriptive markup in actual use. However, IBM researcher Charles Goldfarb is more commonly seen today as the father of markup languages. Goldfarb hit upon the basic idea while working on a primitive document management system intended for law firms in 1969. And helped invent IBM GML later that same year. GML was first publicly disclosed in 1973. In 1975, Goldfarb moved from Cambridge, Massachusetts to Silicon Valley and became a product planner at the IBM Almaden Research Center. There, he convinced IBM's executives to deploy GML commercially in 1978 as part of IBM's document composition facility product, and it was widely used in business within a few years. SGML, which was based on both GML and GenCode, was developed by Goldfarb in 1974. Goldfarb eventually became chair of the SGML committee. SGML was first released by ISO as the ISO 8879 standard in October 1986. Troff and nROT. Some early examples of computer markup languages available outside the publishing industry can be found in typesetting tools on Unix systems such as Troff and nROT. In these systems, formatting commands were inserted into the document text so that typesetting software could format the text according to the editor's specifications. It was a trial-and-error iterative process to get a document printed correctly. Availability of WYSIWYG publishing software supplanted much use of these languages among casual users, though serious publishing work still uses markup to specify the non-visual structure of texts, and WYSIWYG editors now usually save documents in a markup language-based format. TeX, another major publishing standard, is TeX, created and refined by Donald Knuth in the 1970s and 80s. TeX concentrated on detailed layout of text and font descriptions to typeset mathematical books. This required Knuth to spend considerable time investigating the art of typesetting. TeX is mainly used in academia, where it is a de facto standard in many scientific disciplines. A TeX macro package known as LaTeX provides a descriptive markup system on top of TeX, and is widely used. Scribe, GML and SGML, the first language to make a clean distinction between structure and presentation, was Scribe, developed by Brian Reed and described in his doctoral thesis in 1980. Scribe was revolutionary in a number of ways, not least that it introduced the idea of styles separated from the marked-up document, and of a grammar controlling the usage of descriptive elements. Scribe influenced the development of generalized markup language and is a direct ancestor to HTML and LaTeX. In the early 1980s, the idea that markup should be focused on the structural aspects of a document and and leave the visual presentation of that structure to the interpreter led to the creation of SGML. The language was developed by a committee chaired by Goldfarb. It incorporated ideas from many different sources, including Tunnicliffe's project, GenCode. Sharon Adler, Anders Berglund, and James A. Marker were also key members of the SGML committee. SGML specified a syntax for including the markup in documents, as well as one for separately describing what tags were allowed, and where a schema. This allowed authors to create and use any markup they wished, selecting tags that made the most sense to them and were named in their own natural languages. Thus, SGML is properly a meta-language, and many particular markup languages are derived from it. For the late 80s on, most substantial new markup languages have been based on SGML system, including for example TEI and DocBook. SGML was promulgated as an international standard by International Organization for Standardization (ISO 8879) in 1986. SGML found wide acceptance and use in fields with very large-scale documentation requirements. However, many found it cumbersome and difficult to learn, a side effect of its design attempting to do too much and be too flexible. For example, SGML made end tags optional in certain contexts, because its developers thought markup would be done manually by overworked support staff who would appreciate saving keystrokes. HTML in 1989, physicist Sir Tim Berners-Lee wrote a memo proposing an internet-based hypertext system, then specified HTML and wrote the browser and server software in the last part of 1990. The first publicly available description of HTML was a document called HTML tags, first mentioned on the Internet by Berners-Lee in late 1991. It describes 18 elements comprising the initial, relatively simple design of HTML, except for the hyperlink tag. These were strongly influenced by SGML GUID, an in-house SGML-based documentation format at CERN. 11 of these elements still exist in HTML4. Berners-Lee considered HTML an SGML application. The Internet Engineering Task Force formally defined it as such with the mid-1993 publication of the first proposal for an HTML specification. Hypertext Markup Language Internet draft by Berners-Lee and Dan Connolly, which included an SGML document type definition to define the grammar. Many of the HTML text's elements are found in the 1988 ISO Technical Report TR 9537 Techniques for Using SGML, which in turn covers the features of early text formatting languages such as that used by the runoff command developed in the early 1960s for the CTSS operating system. These formatting commands were derived from those used by typesetters to manually format documents. Stephen DeRose argues that HTML's use of descriptive markup was a major factor in the success of the web, because of the flexibility and extensibility that it enabled. HTML became the main markup language for creating web pages and other information that can be displayed in a web browser, and is quite likely the most used markup language in the world today. XML is a meta-markup language that is now widely used. XML was developed by the World Wide Web Consortium in a committee created and chaired by John Bossack. The main purpose of XML was to simplify SGML by focusing on a particular problem: documents on the Internet. XML remains a meta-language like SGML, allowing users to create any tags needed and then describing those tags and the permitted uses. XML adoption was helped because every XML document can be written in such a way that it is also an SGML document, and existing HTML users and software could switch to XML fairly easily. However, XML eliminated many of the more complex and human-oriented features of HTML to simplify implementation environments such as documents and publications. However, it appeared to strike a happy medium between simplicity and flexibility, and was rapidly adopted for many other uses. XML is now widely used for communicating data between applications. XHTML since January 2000. All W3C recommendations for HTML have been based on XML rather than SGML, using the abbreviation XHTML. The language specification requires that XHTML web documents must be well-formed XML documents. This allows for more rigorous and robust documents while using tags familiar from HTML. One of the most noticeable differences between HTML and XHTML is the rule that all tags must be closed. Empty HTML tags such as an LT, BR and GT must either be closed with a regular end tag, or replaced by a special form, and LT, BR and GT. Another is that all attribute values in tags must be quoted. Finally, all tag and attribute names within the XHTML namespace must be lowercase to be valid. HTML, on the other hand, was case-insensitive. Other XML-based applications. Many XML-based applications now exist, including the resource description framework as RDF, XML, Xforms, Dorkbook, SO, and the web ontology language. For a partial list of these, see List of XML markup languages. Features. A common feature of many markup languages is that they intermix the text of a document with markup instructions in the same data stream file. This is not necessary. It is possible to isolate markup from text content, using pointers, offsets, IDs, or other methods to coordinate the two. Such standoff markup is typical for the internal representations that programs use to work with marked up documents. However, embedded or inline markup is much more common elsewhere. Here, for example, is a small section of text marked up in HTML. The codes enclosed in angle brackets and LT, like this, and GT, are markup instructions, while the text between these instructions is the actual text of the document. The codes H1, P, and M are examples of semantic markup in that they describe the intended purpose or meaning of the text they include. Specifically, H1 means this is a first-level heading, P means this is a paragraph, and M means this is an emphasized word or phrase. A program interpreting such structural markup may apply its own rules or styles for presenting the various pieces of text, using different typefaces, boldness, font size, indentation, color, or other styles as desired. A tag such as H1 might be presented in a large bold sans serif typeface, for example, or in a monospace document it might be underscored, or it might not change the presentation at all. In contrast, the I tag in HTML is an example of presentational markup. It is generally used to specify a particular characteristic of the text without specifying the reason for that appearance. The Text Encoding Initiative has published extensive guidelines for how to encode texts of interest in the humanities and social sciences, developed through years of international cooperative work. These guidelines are used by projects encoding historical documents, the works of particular scholars, periods, or genres, and so on. Alternative usage. While the idea of markup language originated with text documents, there is increasing use of markup languages in the presentation of other types of information, including playlists, vector graphics, web services, content syndication, and user interfaces. Most of these are XML applications, because XML is a well-defined and extensible language. The use of XML has also led to the possibility of combining multiple markup languages into a single profile, like XHTML plus MIL and XHTML plus MathML plus SVG, because markup languages, and more generally data description languages, are not programming languages. They are more easily manipulated than programming languages. For example, web pages are presented as HTML documents, not C code, and thus can be embedded within other web pages, displayed when only partially received, and so forth. This leads to the web design principle of the rule of least power, which advocates using the least powerful language that satisfies a task to facilitate such manipulation and reuse.